You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome back to the MedX Podcast. I'm Steve Maxson. Today we're talking about medical extrusion, and our guest is Norbert Ansay, R&D Manager at High Performance Medical Solutions, a Proterial Cable America Company. The High Performance Medical Solutions division is an ISO 13485 compliant manufacturer of components and finished medical devices for OEMs worldwide. Before we get into the technical conversation about medical extrusion, Rayne DuPaul, Vice President of Corporate Marketing at Proterial Cable America, has joined us to talk about the recent rebranding of Hitachi Cable America. Rayne, thanks for joining us today to give our listeners the news about your recent rebranding efforts.
Thank you for having me. This is my first podcast experience. So Hitachi Metals, which is actually the parent company of Hitachi Cable America, was acquired by Bain Capital, which is private equity, back in January 2023. So decades ago, we were initially founded as High Tech Profiles, which was and still is machining and fabrication services. And that's still within our plant in Ashaway, Rhode Island. In the late 2000s, we began investing in the medical space. We were offering precision and tight tolerance plastic extrusion for top 20 med tech OEMs. And you would have probably known us back then as HPMS. We were growing with OEM partners in the plastic value stream. We were able to add capabilities and supply impact for critical devices, and apparently somehow gained interest from Hitachi as like a merger acquisition bolt-on for our wire and cable business out of Manchester, New Hampshire. So Hitachi ended up acquiring HPMS in 2016, and it placed us under the umbrella of Hitachi companies. So flash forward to today, we've officially rebranded from Hitachi HPMS to Proterial High Performance Medical Solutions, HPMS. And we're dedicated to the specialized plastics healthcare industry. So we've committed to double-digit growth this year. And with Bain as our backer, we're able to have access to their expertise and their capital investing, which is really allowing us to accelerate transformational growth. And would like to thank our customers and our partners for, working through the paperwork changes as we go through the rebranding efforts. And we're really looking forward to continuing our partnership just as Proterial.
Great. Having been involved in a rebranding, I know how much time and effort goes into it, and it's a really rewarding process. So I'm sure that you found that as well.
Definitely. Yeah, it's been great.
Excellent. Thanks so much, Rayne.
Thank you for having me.
You're welcome. Norb, thanks for carving out some time to join us on the MedX podcast today.
Thanks for having me. Sorry I missed you in Anaheim. I was hoping to make it down there, but I had to switch my plans at the last minute.
Okay, no problem. We'll get you there next time. It was a good show, by the way. A lot of people. Norbert, let's start with one of my favorite topics, and perhaps yours as well, and that's multi-lumen extrusions. But before we do that, please give our listeners a high-level view of your multi-lumen extrusion capabilities.
All right. So, here at Proterial, multi-lumen extrusion is really our specialty. And we get questions all the time, well, what's the most number of lumens you can do, or layers, or, just those kind of generic questions. And the answer is normally, well, it all depends. Because depending on the materials, there really isn't any limit to the designs and configurations, that are possible. And customers come up with new ones all the time that we see. But I would say, the majority of the stuff you see is 4 lumens or less. That makes up a bulk of the work that we're doing here. But, we do see more lumens, 10 or more. And those can be different as well. Usually it's something like a round tube with a round lumen in the middle, evenly spaced round lumens around the outside. But, that's not always the case. So they can be more complex as well.
Yeah, I think you can probably load up the number of lumens when you have a central lumen with symmetrical auxiliary lumens. The real challenge is, when you have asymmetrical profiles with different wall thicknesses, and you're dealing with different flows, and and then throw in some kind of oblong shapes or different geometries, and then you start to get complicated.
Yeah, we can do all that. Uniform wall is ideal. It's not always the case, and obviously round geometry is good as well. Because otherwise, when you get these oblong shapes, the tooling gets more complicated, which longer to build, more expensive. It is possible though. We see that all the time, and it's really just whatever the customer is looking for.
Yeah, I remember working with a common friend, remember Tyler Ware, him developing a complex multi-lumen double D and some, complex shapes. And by the time he iterated the tool, it basically disintegrated.
Yeah. You get to rev
Yeah.
A, B, C, end up at F sometimes. It can be a long process.
Yeah. Tell us a little bit about combining multi-lumen extrusion with bump or taper capabilities.
Yeah. So we see a lot of both those things, and occasionally they are combined. I can think of one example. It was a 7 lumen that we did not long ago. It had a central lumen that was not round, and all the other 6 lumens were spread around the outside, and they were essentially like kidney bean shaped.
Mm-hmm.
And then you combine that multi-lumen geometry with, a lot of, or not a lot, but 6 external stripes. And then, after a few iterations, then the customer was wondering, oh, could we actually do this as a bump tube? So next thing you know, you're combining a number of different technologies or extrusion techniques, and you have a really complex product.
Speaking of combining, are there cases where you're doing a multi-lumen with multi-layers?
Yeah, we see that where, a lot of times you see it'll be a stripe. It could be a multi-layer, but most multi-layers are your typical co-extrusion with just a single lumen, 2-layer or 3-layer,
Mm-hmm.
or you see a single lumens with stripes or multi-lumens with stripes, and you could do any number of designs. And, we've seen 1, 3, 4, 6 stripe. Sometimes the stripe's on the surface, sometimes it's embedded in the wall, sometimes it's like through the entire wall, and that's usually called a window stripe. Mm-hmm. Or a through wall stripe. And sometimes they want, we worked on one product where they had half the tube was one material, half the tube was another, and it was a multi-lumen. All that's possible, but it all comes down to having the right tooling.
Okay. So it's not always a radial opaque stripe, it's for other purposes.
Yeah. Yes, radial opaque is the most common, but sometimes it could be a clear stripe, like I mentioned with the window stripe, where they're trying to see into it for some reason.
Okay.
Or it could be, we do one product where the stripe is actually a indicator on the outside for the orientation of the tube, whether it's for their assembly or for some other operations that are done to the tube. It's like a visual indicator without having to look at the end of the tube and figure out which way it's turned.
Interesting. Multi-lumen extrusion is similar to profile and extrusion in that ideally you need to have the ability to fabricate and machine tooling in-house to support multiple iterations and to support quick turn. Tell us a little bit about your EDM and CNC capabilities in-house.
Yeah, Steve, like you said, I think it's absolutely needed. If you're going to try to do medical extrusion, you got to be able to either make your own tooling or modify it. You have to have at least some capability. And, here at Proterial, we got an entire machine shop, and there's a portion of this machine shop dedicated to our extrusion tooling and supporting the medical tubing side of it. But they have all the equipment that you could need to make the tooling, like CNC lathes, mills, wire EDM's a big one. There's a lot of inspection equipment that you need. We have, optical measurement as well as CMM. Yeah, so it's really important if you're going to try to do any of these custom shapes, because it's, the lead times can be long, and if not to mention if you're wasting time setting something up and then having to tear it down, waiting for modifications. So we're doing it in the same building.
Right. Good point. I mean, you certainly can't wait or rely on the tooling OEMs to develop multi-lumen tubing and maybe get your first iteration, send them the tool, and then a couple of weeks, maybe month later, get a tool you need to be able to turn it around within hours, I suspect, right?
Yeah, for us, I mean, we can, we'll pull the tooling, we can have the machine just drooling, and it could be as quick as an hour, or, it might say, the guy in the machine shop might say, hey, after lunch, I'll have it ready for you. So in the same day, we're turning it around and, not even have to purge or reset up or move on to another job. And then you're trying to get back into the original job, which is not the best way to do things.
Right. I know that you've developed your own, not only tooling, but your own crosshead assembly. So I guess your fabrication and machining capabilities go beyond tooling for extrusion and secondary operations such as tipping, but in some cases you design your own die heads, multi-layer die heads. Tell us a little bit about that capability.
Yeah, most of the stuff we do fits in like your standard head. We have really two sizes we use: the larger 1-inch die and down, and the smaller 1/2-inch die and down. And most of the tooling we make will just fit in that head, and almost all the setups will utilize that. But in some cases, we have to make different deflector with a high flow, channels, or low flow, or sometimes it's just the conventional stuff doesn't work, so we end up we'll even make an entire crosshead custom for a certain. For example, we had a co-extrusion we were working on, and the inner layer had this additive that raised the melting temperature quite a bit, and we ended up, it would burn. You could only run for a short time, and then the inside layer would burn based on the increased temperature. So we developed a custom deflector for that job that had the right flow rates to maximize the amount of time we could run without burning.
Interesting. Norbert, beyond the traditional materials used for minimally invasive applications, your polyurethanes, PBACs, TPU, polyolefins, do you get involved with any high performance, high temperature materials such as PEEK?
Yeah, we get requests for all kinds of high temperature, high performance materials, but PEEK is by far the most popular by a landslide, I would say. And specifically, we see a lot of requests for the Victrex 381 and the 450G. They seem to be widely used. So we're running those all the time. And I know years ago, when I started there, we didn't do a whole lot of PEEK. Every once in a while we might run it, but these days, if you go down in the shop, we're pretty much almost any day you go down there, we'd be running PEEK.
Is that from a size range of small micro extrusions of PEEK and larger? Give us an idea of the range, if there's anything unique in the size range, wall thickness range, or any secondary operations maybe also for value added.
Yeah, we do, a full size range. You see everything from the small, we do a 22 thousandths by, I think it's 17,000, and that gets some secondary operations because they get trimmed into short pieces. We do your typical, 10 thousandths wall and that sort of thing, all right up through the normal size ranges. And at the larger end of the spec, which is actually probably more challenging than the smaller end is, we do one all the way up to a 1/2-inch OD by a 3/16 ID. So that's a very large thick wall for something like PEEK. And some of them now, the secondary ops have been coming around. There's one in particular where we had a request to do some tipping, and our machine couldn't even do the high temperature that PEEK requires, so we had to have the tipping machine upgraded. And then we got the tooling, and we did that, some thermoforming to shape it into a kind of a U shape with a funny angle. And then that was one of the first secondary operations we had to do with PEEK, and we've had a couple more since then. We actually have one now that's should be going through validation shortly, and hopefully everything goes well.
Is it always a crystalline PEEK, or are there ever any requests for amorphous PEEK tubing because maybe they don't need the full physical properties of crystalline PEEK?
Yeah, we've seen requests both ways, and depending on the wall thickness, sometimes you can do it both ways. Certain times it's more difficult to get to get it to cool right, because you got to deal with air cooling and water cooling, and it can be pretty difficult. And some of the customers actually don't request, which is always nice because you can kind of pick the manufacturing method that you want.
Mm-hmm.
But yes, some of them, when you get to a thicker wall, you'll actually extrude it, and it'll almost look like a 2-layer, where the outside cooled quicker and the inside cooled slower. So you get a layer of the amorphous and a layer of the crystalline. So it obviously that's not what the customer's looking for, but those are all hurdles that you have to deal with when you're working with PEEK.
Are any of those situations where you have to kind of do a secondary process to get full crystallinity, annealing of such?
Yeah, that's a process that exists. Ideally, anytime you can avoid doing any secondary processing, that's the way to go.
Right. Understood. Let's shift our gears to high pressure braided tubing. And I know you have a separate operation in Connecticut dedicated to high pressure braided tubing. And there's an interesting story behind how you got involved in that business. And for those that are not familiar, high pressure braided tubing is a high volume component in medtech, and it's used for balloon inflation devices, aspiration devices, and devices to deliver contrast media. I know there's a pretty cool story, Norbert, that you were involved with, and how you went from basically producing no volume of high pressure braided tubing to producing, millions of feet a week. So share with our listeners that story, and just also for some background, and maybe we can go on to a little bit more about the makeup of high pressure braided tubing, what it's comprised of. I know it's polyurethane with a reinforcement. If you can kind of share that first, and then tell us a little bit how you got into that business at the very beginning.
Yeah. So the there's a lot of braided tubing, some of it has, stainless braid or different liners, but when we talk about high pressure braided tubing, we're really talking of 2 layers of a TPU usually, and there's a nylon monofilament braid layer in the middle. So that's what we're talking about. It could be for contrast injection or different things, but essentially for us, we got into braided tubing probably around 2011, 2012. At that time, we weren't making any braided tubing whatsoever, and I'm not really wasn't part of sales, so I don't know if we were getting a lot of requests for it or not, but we did get this one opportunity in particular. It came to us through an outside sales rep through another company we had a joint venture with, and we found this customer who was having trouble with their supplier. They weren't able to meet the demand or whatever their problem was, but it was a big opportunity, and we wanted to take a chance. So management, looked at it, and they took a gamble and really went after the business hard. And, for my part in the whole thing, I was a process engineer on the floor doing a lot of stuff and some tooling design. So when they decided to go after it, ultimately it was me and some other people on the team that had to figure out how to make it. And like I said, we didn't even have a braider or anything. So the starting point for us was we got to get a braider. Didn't know anything about them. So we got a braider, and we started doing just different experiments. We tried a few different TPUs and, different brands. We didn't really know what to do with the core. So we were trying different materials for that. Eventually we found a combination that worked and worked well, because, a big part of the braided tubing is that you have to get the core out at the end. It's just a temporary manufacturing aid. So we did that, made samples, the customer was happy, gave us some production runs, and then, after a while, it just blew up. And as you mentioned, now we had to build a whole second clean room in another facility not far down the road in Connecticut. And over there right now we have 4 extrusion lines, almost 50 braiders. There's more braiders on order. We have another extruder on order from you guys. And, I think right now we're pumping out about 400,000 feet of this specific tubing a week, which is close to 20 million feet a year.
Wow. You mentioned about the number of braiders compared to the number of extruders. Tell our listeners, and so for some of the folks that aren't aware of that ratio of how many braiders per extruders for high pressure braided tubing or for braided tubing, and why that is.
Yeah, braiders are kind of deceiving, because if you actually look at one while it's running, it looks like it's going a million miles an hour, but it's really only making, you're making less than 100 feet an hour. Whereas an extrusion line, you're talking, you could go 50, 100. There's extrusion lines that go, more than 500 feet a minute. So in order to braid enough, you need way more braiders than you do extruders.
That's unfortunate for us, but no, that's great. Thanks for sharing that. Let's talk a little bit about clean rooms. I know that for the production of extrusions, medical extrusions, and sub-assemblies or finished devices for interventional applications, it's usually performed in a clean room environment. But R&D extrusions or R&D prototypes for catheters and sub-assemblies are often performed in a less stringent environment, sometimes referred to as a white room. Tell us a little bit about your clean room strategy, because you kind of go beyond that for what you do in R&D and production.
Yeah, we 10 years ago or so, we only had a white room. There was no clean room, and we did get into more of those assemblies and secondary operations. So then the need arose. We built a clean room that was actually classed as a class 8. We started doing our internal testing, with the particulate testing, and you have to have outside vendors come and certify it. And once that happened, we decided, hey, our extrusion room actually tests pretty well, and without very much additional work, we were able to classify our extrusion as a class 9 clean room, as well as the Connecticut, the braiding facility, as a clean room. So we're currently doing all of our manufacturing in clean rooms.
Yeah, interesting. And R&D.
Our R&D at the moment is being done in the same production environment. We are in the process of building what would be a 4th clean room to the company in the Rhode Island plant. That's going to be dedicated to R&D, and that'll also be a class 9 clean room.
Okay.
We actually have some equipment on order from you for that as well.
Oh, great. Does that allow you to transition from R&D to V&V and production quicker, to have that both of them in a clean room environment?
Yeah, I mean it's convenient. It's better for everything, because the environment's just more controlled. It's cleaner. I don't know. It's just a better environment to extrude, and you don't have to worry about packaging and different things, where some of the customers, they might not have a requirement that says, oh, it has to be made here, but they might have a requirement that says it has to be packaged in a clean room. So,
right.
If you're making it in a clean room anyway, right on through, it makes that more seamless.
Right. Okay. Good point. Let's wrap up our conversation to talk a little bit about how you leverage the synergies between high performance solutions and Proterial Cable's fine wire and cable assemblies technologies for developing single-use endoscopes.
Yeah, so Hitachi Proterial has been supplying fine wire and actually camera assemblies as well to the endoscope OEMs for a while, and we have some endoscope customers where we're supplying extrusion. So naturally, it's a good fit, and we're able to get access to their customers that we might not have before, and they have a presence overseas as well. Because like I said, they're supplying their cables pre-assembled on cameras already to a lot of the OEMs. Okay. So we've had a few projects that we've worked together on.
Does that often involve multi-lumen extrusions for different working channels and cameras and fiber optics and such?
Yeah, I would say it's more common to have a braided shaft as a part of the assembly. That's the most common. But we have one project we worked on with the wire and cable division, where they actually supplied a micro twin axe, I believe it was. And there's like 3 pairs of them, and they go into a tube that also has a working channel. So that was a kind of a collaboration that we did with them, or currently do.
Right. Interesting. Norb, this has been a good conversation. I appreciate your time and you know, the time that you walk through the capabilities and talking about multi-lumen and the clean room and your collaboration with the Proterial on endoscopy. It's been a great conversation. Appreciate it.
Yeah, thanks for having me.
Absolutely.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.